Okay, hello, good afternoon. Good evening, everyone. Can everyone hear me? Tell me.
Good evening, sir.
Yes. Okay, everyone, we can start. So last day we were doing functions. Okay. This week I actually forgot to send the homework. Okay, but tonight I'll send some problems. Okay. Tomorrow we'll discuss. Okay. Can everyone see my screen? Tell me. So last day we had done up to the graph domain and range of y equal to 3 plus root over x plus 1. Okay. Let us start. Okay. Draw the graph domain and range. Okay. This was the last thing we had done. Okay. Give me 1 minute. Okay. Okay, this was the last thing we had done, right? Wait, let me see. Draw the graph domain. Okay, just give me 1 minute. Okay, just let me know everyone whether we have done these problems or not. Okay, question number one for today. Find the range of number one cot square x minus pi by 4. Have we done this? Just let me know. Find the range of cot square x minus pi by 4. Number two, log of base 1 by 10 x square plus 2x plus 2. Have we done this? Tell me everyone.
Sir, I think we have done this. I may be wrong. You check the notes once.
Let me see.
I think we have done this.
I've done this.
Sir, what was the first question?
Cot square x minus pi by 4.
Yes, sir, we have done this questions.
Oh, yes, we have done this, no? X minus box of x.
Yes, sir. See, we have done this question.
Ah, yes, yes, yes. Okay, 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 okay. I got it. I got it. I got it. Oh, okay, I got it. I think I've got it. Okay. Okay. Okay, I got it. Okay, everyone try. Okay, everyone try this out. Hmm. Find the range of this one we have not done. Find the range of tan of pi by 4 into signum function of x square minus 1. Right, everyone? Have we done this? Tell me. Number two.
No, sir.
Mod of x square minus x minus 6. Solve. Quickly solve, everyone. Once I've done it, send your answers. Okay, should I start, everyone?
Sir, I've sent it.
Send it. Send. Yes, Socrates, first part is correct. Raktim, first part is correct. Everyone see the first one. Okay. What have we got? We have got tan of pi by 4 into signum function of x square minus 1. Now, everyone, see x square minus 1 can be greater than 0, can be equal to 0, can be less than 0 also. If it is equal to 0, okay, Shamita, check your answer again. Socrates part 2 is correct. If x square minus 1 is greater than 0, this implies what is signum function of x square minus 1? Tell me, everyone. Signum function of x square minus 1 will be equal to 1.
1.
Over here, signum function of x square minus 1 will be equal to 0. And over here, signum function of x square minus 1 will be equal to minus 1. So we need to substitute 1, 0, and minus 1 in place of signum function. Yes, Memel, part 2 is correct. Yes, Abhipsha number part 1 is correct. Okay. So pay attention, everyone. What have we got? Tan of pi by 4 into 1. This will be equal to tan pi by 4, which is 1. Next one will be tan of pi by 4 into 0, which is equal to 0. Yes, Shomita, your answer is correct. Tan of pi by 4 into minus 1. This will be equal to minus 1. Yes. Shomita, your answer is correct. Part 2. Tell me, Debatri, is it clear? Part 1.
Yes, sir.
And Devank, have you understood part 1?
Yes, sir.
Onini, part 1 is clear. Shomita, part 1 is clear.
Yes, sir.
Okay, quickly solve part 2. Mimel, did you understand part 1?
Yes, sir.
Okay, quickly solve part 2, everyone. The part 2 is also very easy. Pay attention. Onini, part 2 is correct. Ratim, part 2 is correct. Shomita, Mimel, Acha, Shomita, part 2 is correct. Okay, let us start with part 2. Okay, who is left? I think Devank, Vipsha, and Debatri is left. So Devank, Vipsha, and Debatri, pay attention. Part 2. Yeah, Vipsha has sent. Let's see. Vipsha, the first one is which brackets? First brackets, second, or third brackets?
The third bracket.
Third brackets. That is correct then. Okay. So Devank and Debatri, pay attention. We have got mod of x square minus x minus 6. Right. Now, what does x square minus x minus 6 represents? Tell me. What does x square minus x minus 6 represents? Tell me. Devang, can you tell me what does x square minus x minus 6 represents on the graph paper, on the coordinate axis? Tell me. Parabola, right?
So yes, sir.
Okay. It represents a parabola. So, and what will be the roots of this parabola? Tell me.
-2 and 3.
Minus 2 and 3. Right. Debatri, are you getting?
Yes, sir.
Minus 2 and 3. So it will look somewhat like this. Okay. But whenever it is on the negative side, it will move to the, it will be reflected. Right. Means this part of the graph will be reflected above. Yes or no? Because mod cannot be negative. So finally the graph of the function will look somewhat like this. This is for everyone. Are you people getting? Tell me.
Yes.
This is how the graph is going to look like. Okay. Now tell me. Devatri, can you tell me now what is the range by looking at the graph? Range will be close 0 to infinity open, right? Tell me, Devatri.
Yes,
Only
sir.
the positive y-axis is covered. Also, if you want to solve it manually, okay. Method 2. Mod of x square minus x minus 6. You find out its minimum value. What is the minimum value of this quadratic? Tell me. You people know it already. It will be
Minus 6.5.
minus 6.5. Acha. It
So
will be
minus
equal
6.25.
6.25.
Yes.
It will be equal to 4ac. That is 4 into 1 into minus 6. 4ac minus b square by 4. This will give us how much? 24 plus 1, 25. Wait a minute. Plus 1. Oh, minus 24 minus 1. That will give us minus 25 by 4. Okay. So can I say that the range of this function will be equal to mod of closed minus 25 by 4, comma infinity. Okay. That gives us, that gives us closed 0 to infinity. Is it clear to everyone? Devang, are you getting?
Yes, sir.
And Devatri, are you getting? Tell me.
Yes, sir.
Okay. If there's anyone having any doubt, you can ask me. Next, question number 2. Find the range of. Find the range of number 1. Y is equal to x square minus x plus 1 upon x square plus x plus 1. Number 2. Y is equal to 1 upon x square plus x plus 1. Number 3. Y is equal to x minus 1. This sum we did it in quadratic equations also. If you people remember, you will be able to solve it. X minus 1 into x minus 2 into x minus 3 upon x minus 2 into x minus 3. Solve. Okay, Socrates, this is the answer of part 3, right?
Part 3.
Yes, Socrates, part 3 is correct. Question number 3. Find the domain of square root of x power 14 minus x power 11 plus x power 6 minus x cubed plus x square plus 1. Yes, Shomita, part 2 is correct. Is this the answer of part 1 or 2?
Sir, 1.
Part 1 is correct. Devang, part 1 is correct. Memel, part 1 is correct. Okay, I'm solving part 1, everyone.
So can I just give 1 more minute? I
Okay.
solved the part 3 first.
Shomita, part 2 is correct. Memel, part 2 is correct. Yes, Socrates, part 1 is correct. Yes, Raktim, part 1 is correct. Devang, part 3 is correct. Okay, everyone, I'm solving part 1. Okay. So, Abhipsha and Debatri, since you people were not there during quadratic equations, pay attention. Y is equal to x square minus x plus 1 upon x square plus x plus 1. So, what you people need to do is, since x is real, first of all, cross multiply and make a quadratic. Can we write it as y into x square plus x plus 1 is equal to x square minus x plus 1? Tell me. Are you getting Abhipsha and Debatri? Tell me.
Yes, sir. Yes, sir.
From here, taking everything to one side, we'll get x square into y minus 1 plus x into y plus 1 plus y minus 1 is equal to 0. So see, it becomes a quadratic in x. Okay. But when will it be a quadratic? Tell me. Abhipsha, can you tell me when will it be a quadratic? Over here, coefficient of x square is y minus 1. When will it be a quadratic? When y is not equal to 1, right?
Yes, sir.
So case 1, when y is not equal to 1, then only it is a quadratic. Otherwise, it will become a linear. Okay, if y equal to 1. So if when y is not equal to 1, what are we getting? We'll get this x square into y minus 1. It is a quadratic. And since x is a real number, what can we apply? Since x is real, what can we apply? Discriminant greater than or equal to 0. This implies y plus 1 whole square minus 4 into y minus 1 into y minus 1 equal to 0 is greater than or equal to 0. This implies y square plus 2y plus 1 plus 4 into, sorry, minus 4 into y square minus 2y plus 1 is greater than or equal to 0. Tell me. This implies minus 3y square plus 2y plus 8y plus 10y plus 1 minus 4 minus 3 is greater than or equal to 0. Multiplying by minus 1, we'll get y square minus 10y, 3y square minus 10y plus 3 is less than or equal to 0. Tell me. Are you getting Abhipsha and Debatri? Tell me.
Yes, sir. Yes, sir.
Now you people are capable of solving this inequality. Okay. We can factorize this. This will become 3y square minus 9y minus y plus 3 is less than or equal to 0. This implies taking 3y common, y minus 3 minus 1 common, y minus 3 is less than or equal to 0. This implies 3y minus 1 into y minus 3 is less than or equal to 0. This implies y belongs to close to 1 by 3 comma 3. Remember, this will give us our result. The Shobita part 3 is correct. Okay. So Devatri and Oipsha, whenever you get a linear by quadratic, quadratic by quadratic, quadratic by linear, or 1 upon quadratic, every time apply this method. Is it clear? Both of you?
Yes, sir.
Okay. So try this out. Try this out with the second part. You'll get your result. Socrates, right answer. Shomita, part 3 is correct. Raktin, there is a slight mistake in part 2. Also, see, both of you, what will happen when y is equal to 1? Case 2, what will happen when y is equal to 1? Because we need to see whether we have to include 1 or not. When y is equal to 1, x square minus x plus 1, both the numerator and the denominator will be same. So let me see whether we are getting any value of x or not. You see, x square will get cancelled. You are going to get x equal to 0. That means for y equal to 1, x equal to 0 exists. Therefore, y equal to 1 should be included. We have included it. Is it clear? And suppose you people don't get any value of x, okay, then you have to exclude 1. Should be included. Okay. Both of you try part 2 quickly. Devank, number 3 is correct. Ratim, part 3 is correct. Abhipsha, part 3 is correct. Okay. Okay, I'm going to solve part 2. Pay attention. Y equal to 1 upon x square plus x plus 1. Let us start. Let us see. There are two ways to solve. Okay. 1 upon x square plus x plus 1. There are two ways to solve. Pay attention. Okay. No, this is part 2. There are two ways to solve. Okay, method 1. Okay, Shomita, this is the answer of part number 3 or which one it is?
Number 3, sir.
It's correct. Okay, there are two ways to solve. Method 1. First of all, you make a quadratic like y into x square plus x plus 1 is equal to 1. Okay, so you're going to get x square y plus xy plus y minus 1 equal to 0. Okay, so there will be two cases. Case 1, when y is non-zero. When y is not equal to 0, then only you are going to get a quadratic. Okay. Over here, y cannot be 0. If y is equal to 0, then x will be infinity only. Okay. So there will be only one case when y is not equal to 0. Discriminant should be greater than or equal to 0. This implies b squared, that is y square minus 4 into y minus 1 into y must be greater than or equal to 0. This implies taking y common within brackets, what are we getting? Y minus 4y plus 4 must be greater than or equal to 0. This implies y into minus 3y plus 4 is greater than or equal to 0. This implies y into 3y minus 4 is less than or equal to 0. This implies y belongs to open 0 comma 4 by 3 closed. Why open? Because I have considered that y cannot be equal to 0. Tell me. Are you people getting? Everyone?
Yes, sir.
Okay. Devatri, is it clear?
Yes, sir.
Method 2. Method 2, there is another method. What I can do is, you can find out the minimum value of this quadratic. Minimum value of x square plus x plus 1, that is the denominator, is equal to 4ac minus b square upon 4. That is nothing but 3 by 4. Okay. So I can say that the range of x square plus x plus 1 is equal to 3 by 4 comma infinity. Wait, it is x square plus x plus 1 or x square minus x square plus x plus 1? Will be 3 by 4 comma infinity. Okay. So finally, what is the range of this quadratic? Range of the function? It will be 1 by closed 3 by 4 comma infinity. Now 1 by infinity open will be open 0, and 1 upon 3 by 4 closed will be 4 by 3. Is it clear, everyone? Both the methods are equally correct, whichever method you want to try. Okay. Next. Everyone solve number 3. Hello, good evening, Ritam. Can you hear me?
Good evening, sir. Yes, I can.
Ritam. Okay. Okay, Ritam, these are the problems I'm doing. Okay. Go through the recording. I'll be sending the recording in the group. Okay, go through it.
Okay, sir.
Yes, Socrates, your answer is correct. Okay, part 3, everyone, pay attention. Y is equal to x minus 1 into x minus 2 into x minus 3 upon x minus 2 into x minus 3. Pay attention. Okay. So over here, you can cancel off x minus 2 and x minus 3. Pay attention. It's part 3. Over here, you can cancel off x minus 2 and x minus 3. But when can we cancel them out? When
When
can
x
we
is not
cancel out?
equal to 2 and not equal to 3.
Yes, for x not equal to 2 and 3. Right, Ritam, are you getting? When
Yes,
x
sir.
is not equal to 2 and 3, we can cancel them off. So what is the range? So range of the function will be. So what are the values y cannot take? So everyone, y cannot be equal to 2 minus 1 and y also cannot be equal to 3 minus 1 because x cannot be equal to 3. Therefore, the range of the function will be all real numbers except 1, comma 2. Okay, tell me. Anyone having any doubt, you can ask me now. Yes. Last one. Okay, last one I'm solving. Okay, Mimel, did you understand part 3?
Yes, sir.
Okay. And Onrini, did you understand part 2 and 3?
Yes, sir.
Okay. Solve quickly. Okay, everyone, I'm going to solve number 3. Find the domain of x power 14 minus root over. Okay, pay attention. I'm going to solve. Okay. We need to find out the domain of this function. This is number 3. Okay. So everyone, pay attention. 14 is greater than 11. 6 is greater than 3. Okay. So case 1. When x is greater than 1, strictly greater than 1, or you can say equal to 1 also. Okay, greater than or equal to 1. X bar 14 minus x bar 11 is greater than or equal to 0. X bar 6 minus x bar 3 is greater than or equal to 0. And x square plus 1 is strictly greater than 1. Okay, so everyone, I can say that the whole function is greater than 1. Are you people getting? Yes or no? So it is valid. This domain is valid. X greater than or equal to 1. Next, let's check for x lying between 0 and 1, what will happen? Case 2. When x belongs to 0, comma 1. In this case, you people see x to the power 6 minus x to the power 11 is greater than 0, right? And x square minus x cube is also greater than 0. X to the power 14 is anyways greater than 0. And 1 is, okay, anyways greater than 0. So this particular interval is also, should also be included. Are people getting? Tell me. Ritam, Shwamita, you have given the correct answer. Abhipsha, Memel,
Yes, sir.
Anini, are people getting? Devatri, are you getting?
Yes, sir.
Case 3, when x is less than 0. When x is less than 0, Okay, pay attention. Okay, when x is less than 0, the negative side, oh, so x to the power 14 plus x to the power 6 plus x square plus 1 is of course greater than 0. Next we have minus x to the power 11. Minus x to the power 11 will be greater than 0. Minus x square will also be greater than, sorry, minus x cube will also be greater than 0. Hence, the whole function is greater than 0. Okay, so that means whether you take x less than 0, lying between 0 and 1, greater than 1, okay, f of x is anyways greater than 0. Therefore, the whole domain of the function will be all real. Okay, anyone having any doubt, you can ask me. Next, everyone, range of linear by quadratic. Range of linear by quadratic, quadratic by quadratic, quadratic by quadratic. Okay, quadratic by linear, already done. Okay, already done in quadratic equations. Already done in the chapter quadratic equations. So if anyone needs the notes of quadratic equations, send me a text. I'll send you. Okay. Range of all these types of functions, I've already done it in quadratic equations. Next, question number 4. Find the number of roots of the function f of x is equal to 1 upon x plus 1 whole cube minus 3x plus sin x. Solve. Question number 5. Okay, I'm solving number 4, everyone. Pay
So
attention.
can you give 2 more minutes?
2 more minutes. Quickly solve. Okay, try to plot the graph of the function, everyone. Yes, Ritam, your answer is correct. Memel 5 is correct. Ritam, oh no, Raktim, check number 4. Shamita, number 4 is correct. Sokrit, number 4 is correct. Okay, I'm going to solve number 4 first. Pay attention. So, in order to solve this equation, okay, in order to find out the number of roots of this equation, okay, f of x is equal to 0. Okay, try to plot this function. Okay, everyone. First of all, what is the domain of this function? Can anyone tell me? Raise your hand. What is the domain of this function? Quickly. Can anyone tell me what is the domain of this function? Yes, Socrates, tell me.
All real except for -1.
All real except -1. Okay. So find out its value around -1. Okay. But first of all, let us understand whether the function is increasing, decreasing, what is happening. Okay. Let us find out. So first of all, I'm going to differentiate f dash x will be equal to -3 by x plus 1 whole to the power 4. Are people getting? You people know a little bit of differentiation? So, Bhiksha and Devatri, you people know a little bit of differentiation, right?
Yes, sir.
Okay. Ritam, you know?
Yes, sir.
Okay. -3 by x plus 1 whole to the power 4 -3 plus cos x. Now see everyone, -3 plus cos x is less than 0. And -3 by x plus 1 whole to the power 4 is also less than 0. So can I say that f dash x is less than 0? Once you find that f dash x is less than 0, this implies f of x is a decreasing function, is decreasing. Now let us find out its functional value at some points, okay? So everyone, what is f of minus infinity? F of minus infinity will be equal to 1 upon minus infinity. Okay, -3 into minus infinity plus sine of minus infinity. Okay, which will be plus 3 infinity plus 0. So this will be infinity only. Are you people getting? Yes or no? Tell me, Raktim, Devank, are people getting? Memel, Onani, are people getting?
Yes.
Yes.
Now what is f of infinity? F of infinity will be equal to 1 upon infinity -3 into infinity plus sine of infinity. This will also be equal to minus infinity. Okay. Acha, let us find out its functional value at -1 plus and -1 minus. F of -1 plus will be equal to 1 upon -1 plus. Okay. Plus 1. Okay. -1 plus 1 whole cube -3 into -1 plus sine of -1. Okay. This sign won't affect much, but we need to understand what is happening over here. Now, -1 plus 1 is actually 0 plus. So this is 1 upon 0 plus whole cube. Okay, this will become plus 3 and whatever it is, it doesn't matter. Plus sine of -1 plus. Now 1 upon 0 plus is will actually tend to infinity. So -1 plus, it will be infinity. Similarly, what is -1 minus? F of -1 minus, this will be equal to 1 upon 0 minus whole cube. Okay, -3 into -1 minus plus sine of -1 plus. Okay, this will tend to minus infinity. So how will the graph look like? The graph will look somewhat like this. X equal to -1 will be the vertical asymptote. Okay. And the function is always decreasing. So this is how the graph is going to look like. Tell me. Memel, Onrini, Devang, are people getting?
Yes.
Devatri, Abhipsha, are people getting? Yes or no?
Yes, sir.
So how many times it is cutting the x-axis? Tell me. How many times it is cutting the
Sir, two
x-axis?
times.
So it has two roots. Done. Okay, this kind of questions may come in mains. Okay. Try number 5, everyone. Question number 5, we have done it in class 9. And for some people, I have done it in class 8 also. It's a school level problem, everyone. Yes. Abhipsha, your answer is correct. Okay, I think we should solve number 5. Px is a polynomial function with integer coefficients. Remainder when p of x is divided by x minus 1 is 1. And remainder when p of x is divided by x minus 4 is 10. We need to find the polynomial p of x. Find the remainder when p of x is divided by x minus 1 and into x minus 4. Okay. So there are 2-3 things we need to recall from class 9-10. Okay, everyone? Pay attention. Whenever p of x is divided by quadratic polynomial, whenever p of x is divided by a quadratic polynomial, the remainder is, what kind of a remainder you'll get?
A
Linear.
linear remainder in the
Linear.
form of ax plus b, maybe.
Exactly. Is divided by a quadratic. Remainder is always linear. Linear. Okay. Because the degree of the remainder should be just less than the degree of the divisor. So let the remainder be. Let r of x will be equal to ax plus b. So by division algorithm, can I say, that p of x is equal to x minus 1 into x minus 4 into q of x plus ax plus b? Tell me, can I say this? Yes or no? P of x will be equal to x minus 1 into x minus 4 into q of x plus ax plus b. Now over here it is written that p of 1 is equal to 1 and p of 4 is equal to 10. Can you people understand? P of 1 is equal to 1 and p of 4 is equal to 10. Right, because when it is divided by x minus 1, the remainder is 1, and when it is divided by x minus 4, the remainder is 10. So by remainder theorem, p of 1 is equal to 1 and p of 4 is equal to 10. So substitute, p of 1 will be equal to a plus b, which will be equal to 1, and p of 4 will be equal to 4a plus b, which is equal to 10. So I've got two equations in two variables. Let us subtract. Yes, Ritam, your answer is correct. We'll get minus 3a is equal to minus 9. This implies a is equal to 3. A is equal to 3. This implies b is equal to minus 2. Therefore, the remainder is 3x minus 2. I hope it is clear to everyone. Okay. Next. Let us continue. Our next topic is equal or identical functions, everyone. Equal or identical functions. Pay attention. Two functions are said to be equal. You can say are said to be identical. Identical or equal if their graph overlaps. if their graphs overlaps. Okay, that is uh that is two functions are equal. Two functions are equal if number one, domain of f is equal to domain of G. Number two, range of f is equal to range of G. Okay. Number three, f of x must be equal to g of x for every value of x, for every x, for every x belonging to their common domain. Belonging to their common domain. Okay. For every x belonging to their common domain. Okay. Note, what do you think, people? Sin x and cos x, are they equal functions? Tell me. Their domain is same. Their range is same. Are they equal functions? Have same domain
No, sir.
and range. But sin x is not equal to cos x for all x belongs to R. Simply not possible. Okay. Like, see, this is the graph. This is the graph of sin x. Okay. Oh, wait a minute. This is the graph of cos x, sorry. And this is the graph of sin x. Okay. So see, their domain is same, their range is same, but their functional values are not same. They are equal at some specific values of x. So now for these questions, you people raise your hand. Don't write it in the chat, but raise your hand, okay? Question number what? 6. Are the following functions? Are the following functions identical or not? Number 1, y1 is equal to ln x square and y2 is equal to 2 ln x. Raise your hand once you have done it. Y1 is equal to ln x square and y2 is equal to 2 ln x. Only 1%, 2% are raising the hand. For this one, Raktim, tell me.
So if we put minus something in 2 ln x, it will be not will be in domain, but if we put it in ln x, it will become positive. So domain is not equal.
So they are not identical, right?
Yes, yes.
Correct, correct. Domain of y1 is equal to open 0 to infinity, right? While domain of y2 is equal to, sorry, domain of y1 is all real minus 0. Okay. Whereas domain of y2 is open 0 to infinity. Hence, y1 and y2 are not identical. Remember. Next. So over here, everyone, note it down. Whenever n is even, when n is even, domain of ln x to the power n and n into ln x will not be same. Will not be same. But their domain will be same. But their domain will be same if n is odd. Okay. But their domain will be same if n is odd. Next, part 2. y1 is equal to tan x and y2 is equal to 1 upon cot x. Raise your hand. What do you think? Are these functions identical? Okay, for this one, Abhipsha, tell me.
So they're not identical.
They are not identical. Can you tell me why?
So because the domain is not same.
Yes, domain is not same. Domain of y1, everyone. Domain of y1 will be equal to r minus 2n plus 1 whole pi by 2 for all n belongs to integers. Whereas domain of y2 will be equal to r minus, first of all, cot x should be defined. That is n pi minus cot x should also not be equal to 0. So minus 2n plus 1 whole pi by 2. Okay. So they are not identical. This implies they are not identical. Next, part 3. F of x is equal to sec x and g of x is equal to 1 upon cos x. Tell me, raise your hand. Are they identical? F of x is equal to sec x and g of x is equal to 1 by cos x. Are they identical? Yes, Mehmet, tell me.
Sir, I think yes, they are identical.
They are identical. Correct. Okay. They are identical. Domain is same, range is same, everything is same. Tell me. Anyone having any doubt, you can ask me now. Number 4. Signum function of x square plus 1 and sin square x plus cos square x. Tell me. Raise your hand. What do you think? Are they identical? Signum function of x square plus 1 and sin square x plus cos square x. Okay. Yes, for this one, Shomita, tell me.
Yes, sir, they are identical because they have the same domain.
Same domain, range, everything is same. They are identical. Number 5. Sec square x minus tan square x and 1. Tell me, are they identical? Raise your hand. Yes, Socrates, tell me.
Sir, I don't think they're identical because domain of 1 2 is like all real maybe, and for sec square x minus tan square x, the domain is all r reals minus 2n plus 1 pi by 2. So they're
Correct,
different
correct,
domains. They cannot be
correct.
identical.
Very good, very good. They are not identical. They are not identical as the domain of sec square x minus tan square x is all real minus 2n plus 1 whole pi by 2. Okay. Next. Okay, next. Part 6. Okay. Part 6, f of x is equal to x plus 1 by x. Sorry. Part 6 is equal to f of x is equal to 1 upon 1 plus 1 by x. And g of x is equal to x upon 1 plus 1 by x. X upon 1 plus x. Tell me, are they identical or not? Yes, for this one, Abhishek, tell me.
So they are not identical because the domain of f of x it will be all real minus 0 and of g of x it will be all real minus minus 1.
Correct. Domain of f is all real minus elemental 0, and domain of g is all real minus elemental minus 1. So they are not identical. Okay. Part 7. Okay. Part 7. f of x is equal to box of fractional part of x, and g of x is equal to fractional part of box of x. Tell me, are they identical or not? Raise your hand. Yes, Socrates, tell me.
So they are identical because both have the same domain, that is all reals, and same range, that is 0.
Correct. Domain of f is equal to domain of g. Range of f is equal to range of g. Hence, they are identical. Okay. Next, number 8. F of x is equal to cot square x. Others also raise your hand. I can see every time same hands are being raised. Cot square x into cos square x, and g of x is equal to cot square x minus cos square x. Raise your hand. Are they identical? Shomita, tell me.
Sir, they are identical because when sin x is 0, then they are undefined and domain is same.
Domain is same. How are how are their functional values same? Are you sure their functional values are same?
Sir, they are the same expression.
What? One of them is cot square x into cos square x. Another one is cot square x minus cos square x.
So the domain is r minus n pi.
Domain is r minus n pi. Correct. Cot square x should be defined. Tell me, Shomita,
Yes, sir.
are their functional values same? Let us see everyone. This one I'm solving. Can I write f of x as? Can I write f of x as cot square x into 1 minus sin square x? Tell me. This will give us cot square x minus cot square x into sin square x will become cos square x. Yes, so they are identical, right? Tell me. Hence, they are identical. Number 9. It's number 9, right? Number 9. Raise your hand, everyone. Raise your hand. So similarly, tell me what is f of x into tan square x into sine square x. Other one is g of x is equal to tan square x minus sine square x. Tell me, are they identical? Raise your hand. Tell me, raise your hand. Yes, Mimel, tell me.
Sir, I think they are identical.
Why? Why are they identical? Why are they identical? Tell me.
Sir, like domain same.
Domain is same, but are their functional values same? Can you prove that f of x is equal to g of x at every value of x? Tell me. Okay, see. Everyone see tan square x into sine square x. Can I write it as tan square x? Yes, Raktim, tell me.
So see, if we put sine square is equal to 1 minus cos square x, we are directly getting the function.
Yes, yes, yes. Right, tell me, Memel.
Yes, sir, we can prove it.
So they are identical. Number 10. Tell me, everyone, this one. F of x is equal to log e to the base x and g of x is equal to 1 by log x to the base c. Raise your hand. Tell me, everyone. Are they identical? Are they identical? Tell me. Okay, who is raising the hand? Yes, Raktim, tell me.
Yes, sir.
Yes, they are identical. Domain is same. Range is also same. Domain will be what? R minus all real except.
0.
Okay,
R
wait.
minus non-negative.
First of all, x should be greater than 0 and x cannot be equal to 1. Right.
0 to infinity minus 1.
Yes. Same thing is the domain of G. Okay, and of course their functional value is same. It's just the reciprocal. Next, so they are identical. So they are identical. Number 11. Tell me this one then. F of x is equal to log of x to the base c and g of x is equal to 1 upon log of e to the base x. Tell me, are they identical? Yes or no? Raise your hand. Are they identical? Yes. Only one person, same kind of hands, everyone. What about Ritham, Onani, Devang? Raise your hands. Okay, for this one, Shomita, tell me.
So not identical.
They are not identical. Why?
So because the domains are different.
Yes. What is the domain of F? Tell me.
Sir, for like for log of x to the power base e, it is defined when only x is greater than 0.
Correct. 0, open 0 to infinity.
Yes, sir. But for gx 1 by log xe, that is defined for x greater than 0, but when x is not equal to 1, then only.
0 to infinity except 1, elemental 1. Yes, correct. So we can say that they are not identical. Okay, one last one, number 12. Tell me quickly. F of x is equal to root over x square minus 1, and g of x is equal to root over x minus 1 into root over x plus 1. Tell me, are they identical? Yes, Raktim, tell me.
So not identical. The domain are not same.
Exactly. Not identical. What is the domain of f?
So all real and
All real.
the G.
Are you
So
sure all
0
real?
will be excluded, sir.
Huh?
Sir, for domain of f, 0 will be excluded from the set of reals.
Okay, so we can substitute 0.5, right?
Sorry, I'm to be specific. Minus infinity to minus 1 closed, union 1 to infinity. Sorry.
Correct, correct. Minus infinity to minus 1 closed, union 1 to infinity, right?
Yes.
Tell me, Raktim.
Yes,
And Raktim, tell me what is the domain of G?
sir, x greater than 1. I mean greater or equal to 1.
Greater than or equal to 1, correct. Next, everyone. Our next topic is classification of functions. Classification of functions. Number 1, 1 function. Or you can say injective mapping. 1 function or injective mapping. Pay attention. A function f maps A to B. A function f maps A to B is said to be 1, is said to be 1, or injective mapping, or injective mapping if different elements, if different elements of A have different f images. Okay, means all the elements, each and every element will have different f images, different images in B, have different f images in B. Okay, that is, if f of x1 is equal to f of x2, this implies x1 is equal to x2. Okay, and vice versa. Okay,
Sir, can you please
and
roll up
vice.
once?
Yes. Okay. So everyone, I'm going to draw the mapping, and with the help of the diagram, I'm going to show you what do we mean by injective mapping. So everyone, let us say a function is defined from A to B. Okay, this is A, this is B. A function is defined from A to B. So everyone, this is injective mapping. Okay, this is what injective mapping is. Okay, I'll give you another diagram. You people have to tell me whether this is injective or not.
So in between, I got disconnected. Can you once more explain this one-to-one function? I couldn't hear you properly.
Yes, one-to-one function means a function f maps A to B is such that different elements of A. Okay, means each and every element of A have different images in B. Okay, that is, if I say f of x1 is equal to f of x2, this implies x1 is equal to x2, and vice versa. Okay,
Right. Understood.
like see, each and every element in A has only one image in B. So what do you think, everyone? The second diagram is injective or not?
No, sir.
No, sir.
No, the second diagram is not injective. Next, let us talk about another one. Is this mapping injective? Is this mapping injective? There are two elements in B which do not have any pre-image. Tell me.
Yes, sir.
Yes, sir.
This is also injective. And over here, range is a subset of codomain. Range is a subset of codomain. Acha, I'll give some examples also. For example, let f of x is equal to x plus 1. Of course, it is injective, everyone. Over here, you see, if you substitute f of x1 is equal to x2, f of x2, this implies x1 plus 1 is equal to x2 plus 1. 1 will get cancelled, you will get x1 is equal to x2. Okay, therefore f is 1, 1. Right, Ritam, are you getting? Ritam, Abhipsha,
Yes, sir.
Raktim,
Yes,
Shamita,
sir.
Devang, are people getting?
Yes, sir.
Acha, what do you think? F of x is equal to e to the power x. Is it 1, 1? It's also 1, 1. Why? You see, if e to the power x1 is equal to e to the power x2, then this is only possible when x1 is equal to x2. Okay, everyone. Next, f of x equal to x cube. What do you think? Is it 1, 1? It's a cubic. It is also 1, 1. Because you see, f of x1 is equal to f of x2. This will imply x1 cube is equal to x2 cube. Okay, this implies x1 is equal to x2. Okay, next, what do you think? F of x equal to x to the power 8. Is it 1, 1?
No, sir.
It's not 1, 1. Okay, so I'm going to generalize this for a polynomial.
Sir, x raised to any even power will never be 1, 1.
Yes, generalization. A parabolic graph is never 1, 1. If x1 to the power 2n minus 1 is equal to x2 to the power 2n minus 1, this implies x1 is equal to x2. Okay, hence f of x is equal to x to the power 2n minus 1 is always a 1, 1 function. Okay, methods of identifying injective function. Methods of identifying an injective function. Methods of identifying an injective function. Pay attention. Method 1, using graphs. If you know how to draw the graph, just draw the graph. Okay, you'll be able to understand. So everyone, if a line parallel to x-axis, Memel, are you getting? Cuts the graph of the function of the function in at least two distinct points. In at least two distinct points.
Sir, can you hear me?
Yes, I can
Hello.
hear you. Yes,
Okay,
yes, I
sir.
can hear you.
Okay, sir. Okay,
In
sir.
at least two distinct points, then f is many one. Then f is many one. That is not 1, 1. That is not 1, 1. Okay, for example, f of x is equal to sine x. Of course, it is many one, everyone. Okay. So how will I'm going to draw the graph of sine x and I'm going to show you how we can determine by a line parallel to x-axis that it is many one. So everyone, this is the graph of sine x. You draw the line y equal to half, everyone. Okay. Draw the line y equal to half. So everyone, can you tell me the coordinates of this point and this point? Tell me. What are the coordinates of this point? Tell me. What are the coordinates of this point? This is
Pi
the
by
line
4
y equal to half.
1 by root 2.
What?
Pi by
This
4
is half,
1
half,
by root
half.
4.
Line is half. Quickly tell me for what value of theta sine theta is equal
Pi
to
by
half?
6 comma 1 by 2, sir.
Pi by 6 comma 1 by 2. And what is the next one?
5 pi by 6 comma 1 by 2.
Pi by 6 comma 1 by 2. So can you people see for two different values of x, you are getting the same value of y. Over here, the mapping looks somewhat like this. Pay attention. Okay. For pi by 6 and 5 pi by 6, you are going to get the same value. See, that is half. Okay. So here we can see that y equal to half cuts sine x in at least two distinct points. In at least two distinct points. Two distinct points. Okay. Next. Question number. Okay, so let us do some problems, everyone. You people also identify some 1, 1 functions using the graph. Question number 7. Question number 7. Find whether the following functions. Find whether the following functions. Find whether the following functions are 1, 1 or not.
Sir, if a function is not 1 1, what do we call that function? Many 1.
Many one. Number 1. Y equal to box of x. Raise your hand. What do you think? Is it 1, 1 or many one? Quickly. Okay. Only tell me.
So it's many one.
It's many one. Absolutely correct. Y equal to box of x is many one. As you can see, you will definitely get a straight line parallel to x-axis, which will cut the graph in more than 2 points. If you people have any doubt, you can ask me. Okay. You see, to draw the line y equal to 2. It will cut the graph of the function in more than 2 points. Next. Number 2. Raise your hand. So y equal to box of x is many one. Y equal to fraction part of x. Tell me. 1, 1 or many one? Raise your hand. Yes, for this one, Socrates, tell me.
So many one.
Is also many one. Very simple, everyone. Again, you see the graph. See the graph of the function, everyone. This is how it is going to look like. Ritam, are you getting?
Yes, sir.
Raktim, Shamita.
Yes, sir.
Okay. See, over here also you will get a straight line parallel to x-axis, which will cut the graph in at least 2 points. Okay, next. For this one also raise your hand. Number 3. Y equal to 1 by x. 1, 1 or many 1. Tell me. I have drawn a lot of times, everyone. This graph, yes, for this one, Abhisha, tell me.
Sir, 1, 1.
Y equal to 1 by x is 1, 1. Okay. It will be a parabolic graph, I mean hyperbolic graph, rectangular hyperbola in the first and the third quadrant. Okay. This is how it is going to look like. So you will never get a straight line parallel to x-axis, which will cut the graph in 2 distinct points. Okay. Next. Number 2. Wait, number 4. Y equal to 1 by x square. 1, 1 or many 1? Raise your hand. Yes, Socrates, tell me.
So many one.
Y equal to 1 by x square is many 1. Very easy. 1 by 2 square is also same. 1 by minus 2 square is also same. Without even graph, you can understand. But how will the graph look like, everyone? Pay attention. It will also be hyperbolic in the first and the second quadrant. You people can understand, right? It is an even function. Whatever graph you draw on the right hand side of y-axis, same graph you draw it on the left hand side of y-axis. Okay. Also, you see 1 upon x1 square is equal to 1 upon x2 square. This implies x1 square is equal to x2 square. This implies x1 is equal to plus minus x2. Next, number 5. Y equal to sin x is many 1. Everyone knows. Okay. Number 6. Y equal to cos x is many 1. Number 7. Y equal to tan x. Somebody tell me what is y equal to tan x? 1, 1 or many 1? Tell me, raise your hand. Yes, for this one, Raktim, tell me.
So many one.
Many 1. Everyone knows. Part 8. Y equal to x is also 1, 1. Okay. Number 9. Y equal to x square is many 1. Number 10. Y is equal to x cubed is 1, 1. Number 11. Y is equal to mod x. Tell me, everyone. Mod x. 1, 1 or many 1? For this one, yes. For this one, Raktim, tell me.
Many one.
Many 1. Next. Number 12. Y equal to signum function of x. 1, 1 or many 1? Tell me. Yes, Socrates, tell me.
So many one.
Many 1.
But sir, if you specify that signum x will give you the output as -1, in that case it will become 1, 1.
Couldn't understand. Signum x will give us output as?
If you specify that signum x gives you either -1 or 0 or 1, then when signum x gives -1, that means for whatever value of x less than 0 you give. you will obviously get -1, right? So I think in that case, it is 1 1.
No, you are mistaken.
Oh, right, yes.
Signal.
I understood, sir. X1 equal to X2 has to be single value, right?
Hmm. Okay, number 13. 13. I said 13, so just now I gave y equal to e to the power x is 1, 1. Okay, very simple. Okay, you see y equal to e to the power x will look somewhat like this. Okay, you will never find a straight line parallel to x-axis which will cut the graph at two distinct points. Next, method 2. Method 2, another way of determining injective mapping is differentiating. Okay, pay attention. Differentiating the curve, actually finding the slope of the curve. Everyone pay attention. So everyone, basically what does differentiation of a function at a point gives us? It gives us the slope of the tangent, right? So this is the curve. Okay, if you want to find out the slope of the tangent at 1 comma e, okay, let us say that this is the tangent at 1 comma e, okay, and this angle is theta. Okay, so everyone, first of all, what you have to do is uh, you have to differentiate. Over here, tan theta will be equal to dy by dx. Okay, so dy by dx will give us the slope of a curve at a particular point. Okay, next. Next thing we need to understand what is local maxima. Local maxima. Pay attention. Local maxima is actually the maximum value of the curve. Maximum value of the curve in a particular interval. In a particular interval. Okay. So everyone, if this is the curve, okay, you people are able to understand what will be the local maxima. Let us say that at x equal to a, you are getting the local maxima. Okay, this is the point a comma 0. At x equal to a, you are getting the local maxima. Okay, I'm going to draw few tangents. Okay, I'm going to draw few tangents. This is tangent number 1. This is tangent number 2. Okay, this is a tangent at x equal to a. Okay, this is another tangent. And this is another. Wait, what happened? Oh. And this is another tangent. Okay, see when you go from left to right. Achha, this angle is theta. Okay, everyone, this angle is theta. So what is this angle, everyone? This angle is acute or obtuse? Tell me.
Acute angle.
Acute angle. So can you people understand that over here at this point dy by dx is positive? Tell me. Next, over here also, see it is an acute angle. Can you people see that over here dy by dx is also positive? Tell me. Abhipsha, Andini, Raktim, Shamita, Memel, Devank, are you people getting? Yes or no?
Yes,
Yes,
sir.
yes, sir.
Okay. Next, at this point, what is dy by dx? At the peak point. Tell me. What is the angle it creates with the x-axis? Tell me. What is dy by dx at this point? Quickly tell me, everyone. What is the angle it creates with the x-axis? These two lines are parallel, right? So angle is 0. Tan theta is 0. So at a peak point, you are going to get 0. Next. What is this angle? This angle is acute or obtuse? Tell me. For this tangent,
Obtuse.
obtuse. Tan theta is negative.
Negative.
Again, for this one also. dy by dx is negative. Okay, everyone. So see, let us call this as alpha. Okay, tan theta is positive, tan alpha is negative. So over here, what we can observe, Abhisha, you understood the concept? Here
Yes,
we
sir.
can see that the tangent at local maxima, that the tangent at local maxima, that the tangent at local maxima is a horizontal line, is a horizontal line parallel to x-axis. Okay. Here we can see that the tangent at local maxima is a horizontal line parallel to x-axis. Okay. So dy by dx. So dy by dx at local maxima will be equal to 0. Okay, this is the first thing we need to observe. Next. Here we can also see, we can also see that all the tangents before a comma 0, that all the tangents before x equal to a, before x equal to a makes acute angle with the x-axis, makes acute angle with the x-axis. Okay, makes acute angle with the x-axis. Hence, dy by dx, okay, will be equal to tan theta will be greater than 0. Okay, before a. Okay, everyone. Before a. Or you can write it for x less than a. Okay. Next, while we can see, while we can see that all the tangents after, we can see that all the tangents after the point, after the point a comma 0 makes obtuse angle, makes obtuse angle. Okay. So dy by dx will be less than 0. Okay. So we can observe a sign change in dy by dx around a. So we can observe a sign change. Sign is changing from positive to negative. Okay, everyone. So thus we can see, thus if there is a sign change, there is a sign change, thus if there is a sign change from positive to negative, from positive to negative of dy by dx at x equal to a, at x equal to a, then local maxima exists at x equal to a. Then local maxima exists at x equal to a. Are you people getting? Tell me, everyone. What is local maxima and how it will exist? Tell me. Memel, Kaktim, Devang, Sokroit, Onrini, Shomita, Ritam, Abhipsha. Are you people getting? Tell me.
Yes, sir.
Yes. Ritam, you said something?
No, sir.
You understood, right?
Yes, sir.
Okay. Tell me, Abhipsha, is it clear?
Yes, sir.
Okay. Next. So what will happen, everyone? So if a function has local maxima, so if a function has local maxima, function has local maxima, okay, then there exists a horizontal line. Then there exists a horizontal line which cuts the curve, which cuts the curve in two distinct points, which cuts the curve in at least two distinct points. Okay, you can see. Okay, this is how the curve will look like. Okay, and you'll find a straight line parallel to x-axis, cutting the curve in at least two distinct points. Thus, the function becomes many one. Thus, the function becomes many one. Okay, if there's anyone having any doubt, you can ask me. Next. So similarly, we have something called local minima. Okay, just like we have local maxima, over here we have got local minima. Okay, local minima means minimum value of a function, minimum value of the curve or of the function of the curve in a particular interval. In a particular interval. Okay. So how will the diagram look like? Yeah, how will the diagram look like? Pay attention. This is how it is going to look like. Okay. Okay, I'm going to draw some tangents. Okay, 2, 3 tangents. See, this is where the local minima exist at x equal to a. Okay. And see, all the tangents before a are making obtuse angle with the x-axis. That means tan theta is less than 0. Okay. All the tangents before x equal to a are making obtuse angle with the x-axis. And all the tangents after x equal to a are making acute angle. You see, this is theta, this is alpha. Okay. So here we can see that the sign change. Here we can see that the sign of dy by dx, that the sign of dy by dx changes from negative to positive about a point A. About a point A. Then local minima exists at, and local minima exists at x equal to a. Okay. And how will the diagram look like? This is a. On the left hand side of a, dy by dx is negative, and on the right hand side of a, it is positive. Okay. So everyone, over here also we can say that if a function has local minima, if a function has local minima, then it is many one. Then it is many one. Then, if there's anyone having any doubt, you can ask me. You see, whenever a local minima exists, okay, you'll always find a line parallel to x-axis, which will cut it at two distinct points. Okay, minimum at two distinct points. Next. So everyone, what we can see that if dy by dx is greater than or equal to 0 for all x belongs to domain, means the sign should not change. Okay, if it is positive, it is always positive. Okay, the sign should not change. So dy by dx is greater than 0 for all x belongs to domain. This implies the function is 1 1. Okay, next. Or if dy by dx is less than or equal to 0 for all x belongs to domain, this implies the function is 1 1. So are people getting? When can we say that the function is 1 1? Tell me. Alini, Aviksha, Raktim, Devant, are people getting? Ritam, are you getting?
Yes, sir.
Savita,
Yes, sir.
Sakrit, are you getting?
Yes, sir.
Okay. Okay. Next. Does anyone having any doubt? You can ask me. Okay. For example, you see how we can use this method dy by dx. Okay, to understand whether the function is completely increasing or completely decreasing. So if y equal to x cube, everyone, if y equal to x cube, dy by dx will be equal to 3x square. Okay. And what is the, so everyone, you can see that dy by dx, which is 3x square, it's always greater than or equal to 0. Okay. So see, the function is always increasing. Okay. Hence, you won't find a straight line parallel to x-axis, which is cutting the graph at two distinct points. Next, I give another example. Y is equal to e to the power x. You see, everyone, wherever you draw tangents, wherever you draw tangent to this curve, it will always make. Now, what angle it is making? Tell me, everyone. All the tangents to this curve, what angle it is making? Tell me. What angle it is making? Acute or obtuse?
Acute.
Acute angle. So dy by dx is always greater than 0, everyone. If y is equal to e to the power x, okay, implies y dash is equal to e to the power x only. It's always greater than 0. Okay. For all x belongs to real. For all, that thing are you getting? X belongs to real. Hence, you can say e to the power x is 1 1. Achha, tell me. Another example. This is example number 1. This is example number 2. Example number 3. What about y equal to ln x? Y equal to ln x. Do you think it is 1 1? What angle it is making? Acute or obtuse?
Acute.
Acute. Everything acute. Okay. Next. So that is also 1, 1. Number 3. Y equal to log x to the base half. Is it 1, 1? What do you think? Y equal to log x to the base half. How will the graph look like? The graph will look somewhat like this. Tell me, what is the angle all the tangents are making? What is the angle? 40s. Okay, everyone. Tell me, have you understood how we can understand whether the graph, how we can understand whether local maxima exist or not, and how we can understand whether the function is injective or not with the help of dy by dx. Tell me, has everyone understood? Tell me. Hello.
Yes,
Are
sir.
people getting? Okay.
Yes, sir.
See everyone, note it down. So just now we learned that f of x, f dash x is greater than or equal to 0, or f dash x is less than or equal to 0. The function is 1, 1. But everyone, today we did a problem. Today we did a problem. Pay attention. Today we did a problem. Yes, this. Over here, f dash x was always less than 0. Over here, f dash x was always less than 0. But is the function 1, 1? Tell me. Over here, f dash x is always less than 0. But is this function 1, 1? Tell me, everyone. Look at the
No,
graph
sir.
and tell me. It's not 1, 1. Okay. Hello. Ornini, Raktim, are people getting? Devang, Ritam, are you getting?
Yes, sir.
Or you will definitely find a straight line parallel to x-axis, which will cut the graph into distinct points. Definitely you will find it. Okay. So over here also the many one. Write it down. Over here, the function is, okay, write it down. F of x is equal to 1 upon x plus 1 whole cube minus 3x plus sin x. Over here, the function is many one. Okay, even though it is a decreasing function, even though it is a decreasing function, even though it is a decreasing function, still it is many one. Okay, as you can see that there is a point of discontinuity. As there is a point of discontinuity. So function is many one. I hope it is clear to everyone. Next.
So that means when there is a point of discontinuity, it would be a many one function.
No, not necessarily. You have to draw the graph and check whether it is 1, 1 or many one. Okay. Sometimes it will be many one, sometimes it will be 1, 1. Okay. So whenever there
Okay,
is a
sir.
point of discontinuity, you have to check by drawing the graph. Okay. Next, everyone. Also, we see from the above observations, you can see that if dy by x is greater than or equal to 0 for all x domain, then the function is monotonically increasing. Then the function is monotonically increasing. monotonically increasing. Okay. And if dy by dx is less than or equal to 0, then for all x belongs to domain, then the function is monotonically decreasing. For all x belongs to domain, then the function is monotonically decreasing. Okay. So tell me, till now anyone having any doubt? Tell me. Memel, Onini, Raktim, Oipsha, Devang, Ritam, tell me. Anyone having any doubt till now?
No, sir.
No? Okay. Then we can do some problems. Find whether the following functions. This is question number 8, I guess. Yes, question number 8. Find whether the following functions, whether the following functions are 1, 1 or not. Okay. Part 1. Y equal to 2x plus sin x. Part 2. Y equal to e to the power x plus x. Part 3. Y is equal to x minus 1 into x minus 2 into x minus 3. Solve. Yes, Oipsha, your answer is correct. Everyone pay attention. Number 1. Okay. Raktim, check your answer again. You see, you differentiate once. Yes, Onini, all your answers are correct. You differentiate one. Y dash is equal to sin x plus 2. You see, sin x lies between minus 1 and 1 plus 2. This is always greater than 0. Right, Shomita, are you getting? Shomita,
Yes, sir.
Ritam. Okay.
Yes,
This
sir.
implies And since y dash is greater than 0, okay, this implies y is many 1. Okay. Achha, let us see how will the graph look like. See, it is always increasing. Right, everyone? It's always increasing. Okay. Let us understand the concavity of the graph. Okay. I mean, how the graph will move. Okay. Whether it is increasing, decreasing. Okay. Let us understand. So for this, what you do is you double differentiate. Y double dash will be equal to cos x. Okay. You see, cos x is greater than 0 from 0 to pi by 2. Okay. Cos x is greater than 0 from 0 to pi by 2. So y double dash is greater than 0 when x belongs to 0 comma pi by 2 in this interval. Are people getting? Yes or no? Tell me. Okay. So between 0 to pi by 2, how will you draw the graph? Between 0 to pi by, that means y dash is increasing from negative to positive. Okay. This is how the graph will look like from 0 to pi by 2. Then from pi by 2 to pi, it will look somewhat like this. Are people getting? The concavity will change because dy by dx will be less than 0. Next, same thing below also. Tell me. Have you people understood how the graph will look like? Hello. Wait a minute. Wait a minute, I have done a mistake. Y dash will be equal to cos x plus 2. Sorry. Y
Then it
double
would be
dash will be minus sin x. Sorry. Y. So y double dash will be less than 0. Okay, when x belongs to 0 comma pi by 2. Okay, basically 0 comma pi. Are you people getting? So this is 0. This is pi. Okay. After that, the concavity will change. It keeps on going. Tell me, are you people getting? Abhipsha, Anini, Memel, Raktim,
Yes, sir.
Ritam, Devank, are you people getting how the graph will look like? Devank, is it clear?
Yes, sir.
Okay. Memel, 2 and 3 are correct. Raktim, check part 2. Part 3 is correct. Abhipsha, check part 2. Part 3 is correct. Okay, part 2, everyone, pay attention. Y equal to e to the power x plus x. Okay, part 2. So everyone, y equal to e to the power x plus x. This implies y dash is equal to e to the power x plus 1. Okay. This now over here, e to the power x is always greater than or equal to 0. Okay. This implies the whole function is always greater than or equal to 1. Okay. Therefore, y is increasing. Okay, hence it is 1, 1. Oh, wait. Raktim, your answer was correct only. Therefore, y is 1, 1. Okay, my bad. Okay. Everyone solve the last one? Okay, Memel, can you hear me?
Yes, sir.
Okay. Now the functions which are transcendental, okay, which are not linear or which are not polynomial, okay,
Hmm.
for them dy by dx can be equal to 0 also. Like see, in this case, over here, what is dy by dx at 0, comma 0? It is equal to 0 only. Right, tell me.
Yes.
Okay. So see, but still the function is increasing. At this particular instant, the curve becomes parallel to x-axis. Understood? After that,
Yes.
it keeps on increasing. So it doesn't matter.
Ah. Okay, sir. Okay, sir. Yes.
Yes. Y is increasing, so y is 1, 1. Next, part 3. Devank, are you getting? Devank, Ritam,
Yes.
Yes, sir.
Shamita, are you getting?
Yes, sir.
Okay, part 3. Acha, part 3, can someone tell me? It's very easy. X minus 1, x minus 2, x minus 3. Without differentiating only, you can say. Can you people see that y is equal to 0 for x equal to 1, 2, and 3? Tell me. Can you people understand? Y equal to 0 when x
Yes,
equal to
sir.
1, 2, and 3. So what is it? 1, 1 or many 1? This implies y is many 1,
Many.
right? Right. Tell me, is it clear, Shamita?
Sir,
Good.
part 1 will be
Yes, sir.
many one or one one?
Part 1 will be 1, 1. Oh, acha, I didn't write, na? Wait. Part 1 will be 1, 1. By mistake, I wrote many 1. By mistake. Okay. So tell me, anyone having any doubt till now? No? Okay. Next. One last thing I'm going to discuss today, that is many one functions. Okay, tomorrow again I'll be continuing with 9. Okay, continuing with functions from 9 o'clock. Okay, many one functions. That is not injective. Okay, so function f maps a to b. A function f maps a to b is said to be many one if two or more elements of a if two or more elements of a have the same f image of b. Okay, that is for x1 x2 belongs to a, f of x1 is equal to f of x2, but x1 is not equal to x2. Okay, how will the diagram look like? The diagram will look somewhat like this. Okay, this is how the diagram is going to look like. Next, not only this, This one is also many one. Okay. For example, f maps R to R. F of x is equal to box of x. F of x is equal to mod x. Can anyone give me an example of themselves? I mean, by themselves. Tell me. Anyone
F
give
of
me an
x
example?
means fractional part of x.
F of x equal to fractional part of x. All these are many one functions. What do you think? A quadratic function? Is it one or many one?
Very well.
Many one. Okay. Right. Shwamita, Ritam, are you people getting?
Yes, sir.
Raktim,
Yes, sir.
Devang, Mimel.
Yes, sir.
So all trigonometric functions are
Many one.
many one.
Algebraic functions are also many one.
Algebraic functions are also many one. Hmm? Mimel. All algebraic functions are also many one. Achha, see, a function, a function is either one or many one, right? Either a function will be one or many one. Hence, can I say total number of one mappings?
Sir, my Wi-Fi is fluctuating very much. Can you repeat what you said? Like after I said algebraic, then I didn't have net.
All algebraic functions are many one.
No, no, sir. I was thinking like x square. So it is many
Uh,
one because minus 2n
quadratic,
plus.
quadratic.
Yes, sir, yes.
One mappings plus many one mappings. Total number of one mappings plus many one mappings will give us the total number of functions. Total number of functions that can be defined, that can be defined from defined from set A to set B. Okay. Okay. So till now, anyone having any doubt? The team, Memel, anyone having any doubt?
No, sir.
Devang,
No, sir.
Shomita.
No, sir.
Okay. Okay. So I think we can keep it till now. Tomorrow again we'll continue from 9 o'clock. Okay, 9 p.m. Thank you everyone and good night. I'll send everything in words. Okay.
Thank you, sir.
Thank you, sir. Good
Okay.
night, sir.
Yes.
Good night, sir. Sir, in my I have something to say about the exam.
Okay. Okay. I'll see.
Like
Okay.
after the exam, I saw that I got negative marks in even those questions which I did not attempt. I saw that even in the second paper also.
Okay. I'll see. Actually, I'll check it manually. Don't worry. Okay.
Okay, sir.
Okay.
Thank
Because
you, sir.
because I tried to do some experiment, but it failed. Okay. So I'll check it manually. Don't worry. Okay, Devang.
Oh, okay, sir. Thank you, sir.
Okay. Thank you, Devang. Bye.